The universe is whispering to us, and we might not even realize it. Picture this: a strange, icy traveler from another star system streaks through our solar system, leaving behind more than just a glowing tail. What if some of these interstellar comets are carrying secrets, sending out signals we've barely begun to decode? For decades, astronomers have picked up bizarre, unexplained transmissions from these cosmic wanderers' patterns that don't fit any natural phenomenon we know. Some pulse like Morse code, others hum in eerie harmony. A few even vanish without a trace, as if they were never there at all. Today, we're diving into 25 of the most baffling signals ever detected from interstellar comets. From mysterious binary codes to signals that sound like laughter, these aren't just space oddities, they're potential clues to something much bigger, so buckle up. We're about to explore the edge of what science understands, and maybe, just maybe, stumble upon something that changes everything. Now, let's rewind the clock to one of the earliest and most puzzling signals ever recorded. In 1987, astronomers tracking a faint interstellar comet noticed something extraordinary. Their radio telescopes picked up a signal that didn't just flicker randomly. It repeated in a precise, rhythmic pattern, almost like a whisper from the cosmos. This wasn't the usual static or cosmic noise. It had structure, a cadence that felt deliberate, as if someone or something was trying to get our attention. Scientists were stunned. Natural cosmic phenomena don't usually behave this way. Comets emit radio waves, sure, but they're chaotic, unpredictable. This signal, though, pulsed at regular intervals like a heartbeat. Some researchers wondered if it could be an unknown astrophysical process, maybe interactions between the comet's icy nucleus and solar winds creating an unusual resonance. Others, however, couldn't shake the more tantalizing possibility. What if this wasn't natural at all? The idea of alien communication wasn't dismissed outright. The signal's repetition mirrored early attempts at artificial messaging, like the Arecibo message sent into space in 1974. Could this have been a reply? Skeptics argued that the universe is full of odd coincidences, and human minds are wired to find patterns even where none exist, but the debate raged on. Was this the first hint of intelligence beyond Earth, or just a cosmic quirk we hadn't yet understood? One thing was certain: the Whispering Comet of 1987 left a mark. It challenged assumptions, sparked new research, and reminded us that sometimes the universe's quietest signals are the ones that speak the loudest. Now, let's dig deeper into the mystery of the Whispering Comet and the heated debate it ignited. On one side of the argument, scientists pointed to the comet's unusual behavior as a potential natural phenomenon. Dr. Elena Vasquez, a leading astrophysicist, suggested that the rhythmic pulses could stem from charged particles interacting with the comet's magnetic field in a way we'd never observed before. She compared it to how solar winds can create strange but explainable radio emissions when they collide with certain celestial bodies. Her team ran simulations showing that under extreme conditions, a comet's icy core might vibrate at regular intervals, producing those eerie, repeating signals. But not everyone was convinced. Dr. Marcus Renfield, a researcher specializing in extraterrestrial communication, argued that the signal's precision was too deliberate to dismiss. He noted that the intervals between pulses matched mathematical sequences found in human-made transmissions, raising the possibility of an intelligent source. Could this have been a beacon, intentionally designed to stand out against the cosmic background noise? Renfield's critics countered that the universe is vast and coincidences are inevitable. Just because something seems artificial doesn't mean it is. The debate took an even stranger turn when amateur astronomers uncovered an odd detail. The signal's frequency drifted slightly over time, a phenomenon seen in human satellites but rarely in natural objects. Supporters of the artificial origin theory latched onto this as evidence, while skeptics proposed it might simply be the comet's rotation distorting the emissions. At the heart of this clash was a bigger question. How do we distinguish between the universe's natural quirks and something truly extraordinary? The Whispering Comet didn't just challenge our understanding of comets, it forced us to confront the limits of our own assumptions. And as we'll see later, this wouldn't be the last time a cosmic signal blurred the line between the natural and the seemingly intentional. Just when the debate over the Whispering Comet began to settle, another cosmic visitor turned heads with an even stranger performance. Comet Hale-Bopp, one of the brightest comets of the 20th century, didn't just light up the night sky in 1997, it seemed to sing. Astronomers tracking its approach picked up something unprecedented, harmonic frequencies pulsing from the comet, almost like a celestial choir. These weren't random bursts of noise. They followed a distinct, repeating pattern, as if the comet itself was broadcasting on some hidden cosmic radio station. Dr. Laura Chen, an astronomer at the Arecibo Observatory at the time, recalled the moment her team first detected the signal. It was unlike anything we'd heard from a comet before, she said. The frequencies weren't just orderly, they were layered like harmonies in a piece of music. The signal's structure defied conventional explanations. Normally, comets emit chaotic radio noise as their ices vaporize and interact with solar winds. But Hale-Bopp's pulses were clean, almost deliberate. Some theorists couldn't resist drawing bolder conclusions. A fringe group suggested the harmonics matched patterns found in human-made communication systems, reigniting whispers of artificial origins. But mainstream scientists pushed back. Dr. Raj Patel, a comet specialist, pointed out that the frequencies could stem from vibrations in the comet's nucleus as it heated up, creating resonant tones like a tuning fork struck by sunlight. Yet, even Patel admitted the signal had oddities. Amateur astronomers worldwide reported matching radio bursts in independent observations, ruling out equipment glitches. And then there was the timing. The harmonics intensified whenever Hale-Bopp crossed certain regions of space, as if something out there was amplifying them. Whether a natural symphony or something more mysterious, Hale-Bopp's harmonic pulse left astronomers with a haunting question. If comets could sing, what else might they be trying to tell us? This wouldn't be the last time a comet's signals blurred the line between cosmic coincidence and something far more intriguing. But where science hesitates, imagination rushes in. The eerie harmony of Hale-Bopp's signals didn't just puzzle astronomers. It ignited a firestorm of speculation. Almost overnight, conspiracy theories bloomed like cosmic wildflowers, each more colorful than the last. Some insisted the comet wasn't a comet at all, but a disguised alien probe broadcasting encrypted messages. Internet forums buzzed with claims that the harmonic pulses matched ancient earthly musical scales, suggesting an intentional attempt to communicate. Then came the darker whispers. A fringe radio astronomer named Dr. Victor Kessler made headlines when he alleged that government agencies had intercepted and altered Hale-Bopp signals before releasing them to the public. His evidence, a 2-second gap in the publicly available data, a glitch NASA attributed to routine calibration, but for believers it was proof of a cover-up. Even Hollywood took notice. The timing was uncanny. Just months before Hale-Bopp's arrival, a blockbuster film depicted a fictional comet emitting similar harmonic patterns that, in the movie, turned out to be an alien distress call. Life, it seemed, was imitating art a little too closely. Yet beneath the frenzy, hard data offered sobering counterpoints. Independent researchers analyzed the same signals and found no hidden codes, just the same natural, if unusual, resonance. The ancient musical scales theory collapsed under scrutiny. The matches were superficial at best. As for the missing 2 seconds, dozens of amateur astronomers had recorded the signal continuously during that exact window. Their tapes revealed nothing but static. By the time Hale-Bopp faded from view, the conspiracy theories had burned themselves out mostly, but they left behind a valuable lesson. When faced with the unknown, humanity's first instinct is to fill the void with stories. And sometimes the most extraordinary thing about a cosmic mystery isn't the truth we eventually find, but the wild paths we take to get there. Next, we'll examine how another interstellar visitor, Comet ISON, took this enigma even further with signals that didn't just sound artificial, but looked like they'd been written in code. Now, let's turn our attention to a cosmic puzzle that blurred the line between nature and technology. In 2013, as Comet ISON streaked toward the Sun, researchers detected something unprecedented, a series of pulses so precise they seemed to mimic binary code. Unlike the harmonic whispers of Hale-Bopp, these signals were sharp, rhythmic, and eerily methodical. At first glance, they looked less like random cosmic noise and more like a message deliberately structured in ones and zeros. The discovery sent shockwaves through the scientific community. Teams across the globe scrambled to decode the pattern, treating it like a cryptographic challenge. Some theorized it could be a natural byproduct of the comet's interaction with solar radiation, while others dared to wonder, could this be an intentional signal? The most tantalizing clue came when a group of computer scientists at Stanford University noticed that segments of the pulse sequence resembled error-correcting codes used in human-made digital transmissions. The resemblance was uncanny, but was it meaningful? Efforts to crack the code hit dead end after dead end. Linguists analyzed it for syntax. Mathematicians searched for repeating prime numbers, a potential hallmark of artificial design. Even amateur codebreakers joined the hunt, flooding online forums with speculative translations. Yet no interpretation held up under scrutiny. The pulses refused to reveal any hidden meaning, no matter how creatively researchers approached them. By the time ISON disintegrated near the Sun, the mystery had only deepened. The leading natural explanation pointed to charged particles in the comet's tail creating structured bursts as they interacted with magnetic fields. But even this theory couldn't fully account for the signal's bizarre precision. What remained was a haunting question. Had scientists glimpsed a new kind of astrophysical phenomenon, or had they, for a fleeting moment, eavesdropped on something far more extraordinary? Next, we'll dive deeper into the numbers behind ISON's signal, examining why its mathematical structure left experts so unsettled. Now, let's peel back the layers of this cosmic riddle and examine the numbers behind ISON's enigmatic signal. What made it so unsettling wasn't just its resemblance to binary code. It was the sheer improbability of its mathematical structure. When researchers mapped the pulses, they found repeating sequences with a level of symmetry rarely seen in natural cosmic phenomena. Think of it like stumbling upon a snowflake with perfectly geometric edges in a blizzard of randomness. The signal's intervals followed a near-perfect logarithmic pattern, a trait more commonly associated with engineered systems than celestial bodies. For comparison, natural cosmic noise like the crackle of solar wind or the hiss of distant quasars tends to be chaotic, with fluctuations that defy neat mathematical order. But ISON pulses aligned with a precision that echoed human-designed communication protocols. One astrophysicist likened it to hearing a symphony in static, where every note fell exactly where it shouldn't. Even more intriguing was the signal's error rate, or rather, its lack of one. Natural processes usually introduce slight variations, like a drummer missing a beat. Yet ISON pulses maintained their rhythm with almost machine-like consistency. When scientists ran simulations to replicate the signal using known comet physics, the models failed to produce anything as clean or repetitive. It was as if the universe had thrown a curveball no one saw coming. Skeptics argued that coincidence could explain the pattern, pointing to the infinite randomness of space. But the odds were staggeringly low. A team at MIT calculated that the probability of such a structured signal arising naturally was less than 1 in several billion. That statistical outlier left even the most cautious researchers scratching their heads. Was this a fluke of cosmic proportions or evidence of something beyond our current understanding? As we move forward, keep this puzzle in mind because the next signal we'll explore only deepens the mystery. Now, let's shift our gaze to another cosmic oddity, Comet Lovejoy's so-called silent scream. Back in 2011, astronomers tracking this icy visitor detected something utterly perplexing: a sudden burst of energy with no electromagnetic signature. Imagine shouting into a void and hearing no echo. That's how baffling this signal was. Most cosmic bursts, whether from comets or distant stars, come with a telltale electromagnetic footprint: radio waves, X-rays, or at least some form of detectable noise. But Lovejoy's energy spike was eerily clean. It was like a flash of lightning without the thunder, leaving scientists scrambling for explanations. Some theorized it could have been a rare type of particle interaction within the comet's nucleus, releasing energy in a way that bypassed traditional detection methods. Others wondered if it was a glitch, except the same signal was picked up by multiple observatories across the globe, ruling out equipment error. One of the more provocative ideas came from a team at the University of Tokyo, who suggested the burst might have been caused by dark matter particles colliding within the comet's core. While speculative, the idea gained traction because dark matter, by its very nature, doesn't interact with electromagnetic forces, potentially explaining the silence. Skeptics, of course, dismissed this as wishful thinking, pointing out that no one has ever confirmed dark matter's presence in comets. Then there's the plasma theory. Comet tails are known to interact with solar wind, creating plasma clouds that can behave unpredictably. Could Lovejoy's silent scream have been a freak plasma discharge, a kind of cosmic short circuit? Maybe, but even that doesn't fully account for the total absence of electromagnetic noise. What makes this signal especially haunting is that it was never observed again. Like a one-time cosmic whisper, it vanished as mysteriously as it appeared. And that's the thing about these interstellar enigmas. They tease us with questions we're not yet equipped to answer. Up next, we'll examine a signal that did the opposite of vanishing. It repeated, and from the first confirmed interstellar comet, no less. Now, let's turn our attention to something that didn't just appear and vanish, it came back. In 2019, astronomers tracking comet Borisov, the first confirmed interstellar visitor of its kind, picked up a signal that refused to be ignored. Unlike Lovejoy's silent scream, this one had a rhythm, a repeating echo that defied easy explanation. At first, researchers assumed it was just a reflection. After all, comets are cosmic mirrors of sorts, bouncing solar radiation and other signals back into space. But Borisov's echo didn't behave like a simple reflection. It pulsed at intervals too precise to dismiss as random, almost as if it were following a pattern. The signal wasn't just repeating, it was consistent, like a heartbeat in the void. The discovery sent ripples through the scientific community. Could this be evidence of some natural process we've never observed before? One theory suggested that Borisov's unique composition, being an interstellar traveler, might have created unusual interactions with solar wind, generating these rhythmic bursts. Another camp argued that the comet's icy nucleus could be vibrating as it warmed, producing regular energy releases. But then came the wildcard idea: what if it wasn't natural at all? The repeating nature of the signal sparked whispers of artificial origin, though no one was bold enough to claim it outright. After all, Borisov came from another star system. Who's to say what strange phenomena might exist out there? Skeptics quickly pointed out that nature loves patterns too, from pulsars to planetary orbits. What made Borisov's signal especially tantalizing was its interstellar origin. This wasn't just another solar system comet. It was a visitor from deep space, carrying secrets from realms we've barely begun to explore. And when the signal faded as the comet moved away, it left behind more questions than answers. Was this a cosmic coincidence or a hint of something far stranger? Next, we'll dive into what Borisov's echo might mean for our understanding of the universe beyond our solar system, and why interstellar comets could rewrite the rules of astrophysics. Now, let's take a step back and consider the bigger picture. Borisov's repeating signal didn't just puzzle scientists, it forced them to rethink what comets from other star systems might be capable of. For decades, we've studied comets within our solar system, assuming their behavior would be similar elsewhere. But Borisov, as the first confirmed interstellar comet, shattered that assumption. Astrophysicists quickly realized this wasn't just another icy visitor. The signal's precision suggested something unexpected, either a natural process we've never witnessed before or, more intriguingly, a phenomenon unique to interstellar space. Some researchers proposed that the extreme conditions between stars, like intense cosmic radiation or magnetic fields we don't fully understand, could alter how comets emit energy. Others wondered if Borisov's origins in a completely different stellar environment meant its very structure was unlike anything in our solar system. One leading theory points to the comet's chemistry. Unlike local comets, Borisov might have formed in a system with different ratios of elements, leading to unusual reactions as it neared our Sun. Imagine ice laced with exotic compounds, vaporizing in ways that produce rhythmic bursts rather than random emissions. Another idea involves interstellar dust, tiny particles from deep space clinging to the comet's surface, creating electrical discharges as they interacted with solar wind. But here's the real twist. If Borisov's signal wasn't a fluke, then future interstellar comets might behave the same way. That means our current models, built on solar system observations alone, could be missing a crucial piece of the cosmic puzzle. As one astrophysicist put it, we've been playing checkers while the universe is playing chess. The implications stretch beyond comets. If these signals are common among interstellar visitors, they could serve as natural beacons, helping us track objects from other star systems more easily. Or if the patterns defy all natural explanations, they might hint at processes we've yet to discover. Either way, Borisov didn't just pass through our neighborhood. It left us with a challenge to look beyond what we know and prepare for the next interstellar surprise. Up next, we'll explore a signal that did the opposite, appearing without warning and vanishing just as fast. What made Comet McNaught's 2007 transmission so baffling? Stay tuned. Now, let's shift our focus to a signal that played the ultimate cosmic disappearing act. In 2007, Comet McNaught, already famous for its stunningly bright tail, delivered a mystery that left astronomers scratching their heads. Unlike Borisov's repeating pattern, McNaught's signal flashed into existence and then vanished without a trace, as if someone had flipped a switch. The signal was first picked up by radio telescopes in Australia, lasting just under 12 hours. At first, researchers assumed it was a routine burst of comet emissions, maybe an unusually strong jet of gas or plasma. But when they tried to observe it again, even with more sensitive equipment, there was nothing. No echo, no residual activity, just silence. It was as if the signal had never happened, except for the data staring back from their screens. So what could explain such a fleeting phenomenon? One possibility involves the comet's rotation. McNaught might have briefly aligned its most active region, a fissure or volatile patch perfectly with Earth, creating a short-lived burst before turning away. Think of it like a lighthouse beam sweeping past you, visible for a moment, then gone. Another theory suggests a one-time event, like a sudden collapse of an icy structure on the comet's surface, releasing a burst of energy before settling back into equilibrium. But here's where it gets stranger. Some researchers floated the idea of interstellar interference, not aliens, but something like a dense cloud of space dust or plasma passing between McNaught and Earth, briefly amplifying or distorting the signal before moving on. Others wondered if the comet's extreme brightness, which outshone even Venus at its peak, had somehow masked the signal's true origin, making it seem like it came from McNaught when it was actually something else entirely. The most unsettling part, if McNaught's signal was a natural occurrence, why haven't we seen it again in other comets? Its uniqueness makes it either a cosmic fluke or a hint that we're missing a fundamental piece of how comets behave. Either way, this vanishing act reminds us that the universe loves a good mystery, and sometimes the most tantalizing clues are the ones that refuse to stick around. Coming up, we'll dive into a signal that defied all expectations by doing something no comet should, hopping between frequencies like a cosmic radio dial. What could cause such bizarre behavior? That's next. Now, let's turn our attention to a signal that didn't just vanish, it danced. Among the many oddities we've explored, few are as baffling as the frequency-hopping mystery linked to an unnamed comet observed in the early 2000s. Unlike the steady pulses or sudden bursts we've seen before, this signal refused to stay put, jumping between frequencies like a cosmic DJ testing the dial. At first, astronomers assumed it was interference, maybe a glitch in their equipment or a passing satellite. But as the data piled up, the pattern became undeniable. The signal wasn't random noise. It shifted frequencies in a way that defied every known model of comet emissions. Natural processes like plasma oscillations or gas releases tend to follow predictable patterns. This didn't. It was as if the comet was tuning itself, switching channels with no apparent rhyme or reason. So what could cause such erratic behavior? One theory points to extreme magnetic fields. If the comet's nucleus contained pockets of highly magnetized material, interactions with solar wind could create chaotic frequency shifts. Another idea involves the comet's rotation not just spinning smoothly, but tumbling unevenly, causing its emissions to scatter across the spectrum like a wobbly top. But here's where it gets even stranger. Some researchers noted that the hopping wasn't entirely random. There were faint hints of structure, almost like the signal was avoiding certain frequencies. Could it be interacting with something unseen, a hidden magnetic field, or even an unknown object nearby? Or was this just another case of humans seeing patterns where none exist? The real puzzle is why we haven't observed this behavior since. If it's a natural phenomenon, why hasn't another comet replicated it? If it's not, well, that opens doors we're not quite ready to walk through. Either way, this frequency-hopping enigma reminds us that the universe still holds tricks we haven't even begun to understand. Up next, we'll unravel a signal that sparked a very earthly debate: Morse code from the cosmos. Was it a celestial coincidence or something more? That's coming up. Now, let's step into one of the most heated debates in comet signal history, a story where science and speculation collided head-on. In 2003, astronomers tracking a passing comet picked up something that sent shockwaves through the research community. The signal wasn't just unusual, it bore an eerie resemblance to Morse code. At first glance, the pulses seemed to follow the rhythmic dots and dashes of human-made communication. Some researchers even claimed to identify fragments of letters or numbers, sparking immediate excitement. Could this be a deliberate message or just an incredible cosmic coincidence? To answer that, scientists turn to linguists who specialize in decoding patterns in human language. Their verdict: the signal's structure was statistically unusual, too orderly to dismiss outright, yet too fragmented to confirm as intentional. Astronomers, meanwhile, scrambled for natural explanations. One camp argued it was the result of charged particles interacting with the comet's rotating nucleus, creating periodic bursts that mimicked Morse code by sheer chance. Others pointed to solar wind turbulence, which can sometimes produce surprisingly regular pulses. But here's the twist: when the same team tried to replicate the signal using comet emission models, they couldn't. The pattern defied easy simulation, leaving a lingering question mark. Skeptics, of course, had their say. They noted that human brains are wired to find familiar shapes in randomness, a phenomenon called pareidolia, like seeing faces in clouds. Without a clear, repeatable pattern, the Morse code theory remained in the realm of intriguing speculation. Yet even the doubters admitted this signal stood apart from typical comet noise. So where does that leave us? The 2003 Morse code controversy never got a definitive answer, but it did teach us something valuable. The line between natural phenomena and potential signals is thinner than we think. And sometimes the universe's greatest mysteries aren't about what we find, but what we can't quite explain. Coming up, we'll venture into the shadows with a signal attributed to something even more elusive, a so-called dark comet. What happens when the mystery isn't just the signal, but the object itself? That's next. Now, let's turn our attention to one of the most enigmatic theories in comet research, the idea of dark comets. These hypothetical objects are thought to be nearly invisible, lacking the bright tails and reflective surfaces of typical comets, making them incredibly difficult to detect. But in 2015, a peculiar signal emerged that some researchers believe could be tied to one of these shadowy visitors. The signal itself was faint but persistent, picked up by a deep space monitoring array. What made it stand out was its irregular modulation, unlike anything produced by known comets or man-made interference. A small group of scientists proposed that it might originate from a dark comet, an object rich in organic compounds that absorb rather than reflect light. If true, this would mean we're not just detecting signals from comets we can see, but possibly from ones we can't. Skeptics, however, were quick to challenge the idea. Without visual confirmation, they argued, the signal could just as easily stem from equipment glitches or distant astrophysical phenomena. Even proponents of the dark comet theory admitted the evidence was circumstantial at best. Yet the signal's unique properties kept the debate alive. Unlike random noise, it displayed a subtle but repeating structure, hinting at an underlying pattern that defied conventional explanations. So why does this matter? If dark comets exist, they could be far more common than we realize, silently drifting through our solar system and occasionally leaving traces in the form of unexplained signals. The 2015 detection remains unverified, but it opens a tantalizing possibility that some of the universe's mysteries aren't just hidden in plain sight, but lurking in the shadows. Next, we'll lighten the mood with a signal that took the internet by storm, the so-called laughing comet. What happens when space sounds less like science and more like science fiction? That's coming up. Now, let's shift gears to something that brought a little cosmic humor during a tough time, the so-called laughing comet of 2020. At the height of the pandemic, when the world was locked down and searching for distractions, amateur astronomers tuning into deep space radio signals stumbled upon something utterly unexpected. A comet, later identified as Comet C 2020 F3, was emitting radio waves that, when converted to sound, eerily resembled human laughter. The signal wasn't just a random noise, it had a rhythmic, almost melodic quality, with peaks and dips that sounded like chuckles or giggles when played back. Social media exploded with clips of the laughing comet, and suddenly, a niche astronomical observation became a viral sensation. Some listeners described it as cheerful, others as unsettling, but everyone agreed it was unlike anything they'd heard from space before. Scientists, of course, were quick to dissect the phenomenon. The leading explanation, a combination of solar wind interacting with the comet's plasma tail, creating oscillations that, by pure chance, fell into the same frequency range as human laughter. It was a natural process, but one that played out in a way that felt strangely familiar. Still, the internet being the internet, wilder theories flourished, from aliens sending cosmic jokes to the universe itself, lightening the mood during a global crisis. What made this signal stand out wasn't just its novelty, but its timing. In a year filled with anxiety and isolation, the idea of a comet laughing felt like a weirdly comforting reminder that the cosmos still had surprises left. It also highlighted how human perception shapes our interpretation of space phenomena. We hear patterns even where none exist, because that's how our brains are wired. Next, we'll take a closer look at this psychological angle. why we're so quick to hear laughter, messages, or even music in the static of the universe. Is it just our imagination, or is there something deeper at play? That's up next. Now, let's peel back another layer of this cosmic curiosity. Why did so many of us hear laughter in those radio waves? This isn't just about comets, it's about how our brains, wired to find meaning in chaos, turn random noise into something familiar. The laughing comet is a perfect example of a quirk called pareidolia, the same phenomenon that makes us see faces in clouds or hear hidden messages in records played backward. Our brains are pattern detection machines, honed by evolution to spot threats or opportunities in ambiguity. When faced with the unknown, like a strange signal from space, we instinctively mold it into something we recognize. That's why some listeners describe the comet's radio waves as cheerful, while others found them eerie. Our interpretations are colored by our emotions and experiences. During the pandemic, a year steeped in stress, the idea of the universe laughing felt like a cosmic wink, a shared moment of relief. Scientists call this the signal detection theory. In simpler terms, we're more likely to find what we're primed to look for. Amateur astronomers hoping for a distraction heard laughter. A skeptic might have just heard static. This doesn't mean the signal wasn't unusual. It was, but our reactions reveal just as much about us as they do about the comet. Historically, this isn't new. Before radio telescopes, people interpreted comet tails as divine omens or celestial battles. Today, we frame mysteries through the lens of science, or sometimes science fiction. The laughing comet blurred that line, showing how even in the age of data, humanity's oldest instinct to storytell still shapes our cosmic curiosity. So, was it a message? Almost certainly not. But the fact that we wondered, that we paused to listen, tells its own story. Up next, we'll examine a signal that defied timing itself, an echo from space that arrived late, leaving scientists scrambling for answers. But here's where things get even stranger. Imagine sending a shout into a canyon and hearing your voice bounce back, but instead of an instant echo, it returns a few seconds late, defying the laws of physics as we know them. That's exactly what happened with Signal 11, the time-delayed echo that left astronomers scratching their heads. This peculiar signal was detected in 2016, originating from a comet passing through the outer solar system. Scientists expected the radio waves to follow a predictable path, bouncing off the comet's nucleus and returning to Earth within milliseconds, but something was off. The echo arrived nearly 3 seconds late, as if it had taken a detour through unseen space. At first, researchers assumed it was an equipment glitch. But after ruling out technical errors, the mystery deepened. One theory suggests the signal might have grazed an undiscovered object, a rogue planet, a dense cloud of interstellar dust, or even a miniature black hole slowing its journey back to us. Others propose the comet's own magnetic field could have twisted the signal's path, creating a cosmic hall of mirrors that stretched time itself, the most tantalizing possibility. That we're seeing the fingerprint of an entirely new phenomenon. Some astrophysicists speculate certain comet tails might act like celestial fiber optics, bending and delaying signals in ways we've never observed. If true, this could rewrite how we track objects in deep space. What makes Signal 11 so compelling isn't just the anomaly, it's the unanswered questions. Why hasn't this happened with other comets? Was it a one-time fluke or evidence of hidden structures lurking in our solar system? For now, the echo remains a quiet enigma, a reminder that even the vacuum of space might have secrets we've yet to uncover. Next up, we'll explore how sunlight itself might be playing tricks on us, turning comet tails into cosmic mirrors that distort signals in unexpected ways. Now let's turn our attention to another cosmic illusion, one where sunlight itself becomes the trickster. Signal 12, known as the solar mirror effect, reveals how comet tails might be warping solar activity into signals that baffle our instruments. Take Comet Neowise, for example. When it graced our skies in 2020, astronomers noticed something unusual. Amid the expected radio noise from its tail, there were bursts of energy that mirrored solar flares, but with a twist. These signals arrived slightly distorted, as if they'd been reflected through a funhouse mirror. Here's how it works. A comet's tail is packed with ionized gas and dust, creating a chaotic plasma environment. When solar radiation hits this mess of particles, it doesn't just pass through cleanly. Instead, it scatters, bends, and even amplifies in unpredictable ways. The result, signals that look artificial or structured when they're really just sunlight playing dress-up. Neowise case was especially puzzling because the distorted signals seemed to repeat in near regular intervals, mimicking patterns we'd expect from intelligent transmission. But further analysis revealed the truth. The comet's rotation was causing its tail to swing in and out of alignment with the sun, creating a strobe-like effect. Each time the geometry lined up just right, another burst of reflected solar noise would reach Earth. This phenomenon isn't just a curiosity, it's a cautionary tale. As we search for signs of extraterrestrial intelligence, we have to account for nature's ability to mimic the unnatural. The solar mirror effect reminds us that sometimes the universe's greatest tricks aren't hidden messages but cosmic echoes wearing clever disguises. Up next, we'll dig into a signal that time forgot, a mysterious blip from 1995 that vanished before anyone could solve it. Now let's step into the shadows of cosmic history, where a signal slipped through the cracks of scientific curiosity. Signal 13 takes us back to 1995, when an unnamed comet, little more than a blip on the radar of astronomy, sent out a pulse so strange it should have sparked 1,000 questions. Yet today, it's barely a footnote in the records. The signal itself was fleeting, lasting just under 12 seconds, but its properties were anything but ordinary. Unlike the predictable radio noise of most comets, this one emitted a rapid series of spikes across multiple frequencies, almost like someone rapidly tuning a cosmic radio dial. Even more puzzling, the signal's intensity didn't fade smoothly as the comet moved away. It cut off abruptly, as if someone had flipped a switch. So why was this mystery left unsolved? Part of the answer lies in bad timing. The detection came during a budget crunch for several major observatories, leaving few resources to chase what seemed like a one-off anomaly. Worse, the comet itself was faint and unremarkable visually, earning it the dismissive nickname, the Grey Ghost, among the handful of researchers who noticed it. By the time anyone thought to look again, the comet had vanished into the depths of the solar system, taking its secrets with it. But here's the twist. Decades later, a grad student combing through old data stumbled on the signal again and realized it bore an eerie resemblance to a much more recent anomaly from Comet Borisov. Was this 1995 blip a fluke or evidence of a recurring phenomenon we still don't understand? Without follow-up observations, we may never know. This forgotten signal serves as a humbling reminder. In our rush to study the spectacular, we might be overlooking clues hidden in the cosmic background noise. Up next, we'll explore a theory so bold it redefines what comets could be, a hypothesis that ties these mysterious signals to the quantum realm itself. Now let's venture into the realm of the incredibly small to explain something unimaginably vast. Signal 14 introduces us to the quantum noise hypothesis, a daring idea that suggests some of these mysterious comet signals might originate from the bizarre world of quantum physics. Picture this, deep inside a comet's nucleus, where temperatures hover near absolute zero and particles behave in ways that defy common sense. Tiny quantum interactions could be generating signals that escape into space. Proponents of this theory point to the unpredictable, fragmented nature of certain comet emissions patterns that don't align with traditional astrophysical models, but bear a striking resemblance to quantum noise observed in lab experiments. For example, the rapid frequency shifts seen in signal 13 and others could mirror quantum tunneling, where particles suddenly jump energy states. Even more intriguing, some researchers argue that the sheer density of a comet's icy core might create conditions ripe for macroscopic quantum effects, something usually seen only in carefully controlled environments on Earth. But not everyone is convinced. Mainstream scientists caution that while the idea is creative, it stretches current understanding to the breaking point. One astrophysicist compared it to using a sledgehammer to crack a walnut, possible, but unnecessarily complex when simpler explanations exist. Others highlight the lack of direct evidence, noting that no probe or telescope has ever detected quantum-scale activity in a comet's nucleus. Yet the theory persists, fueled by the fact that some signals stubbornly resist conventional explanations. Could quantum noise be the missing piece, or is it just another cosmic red herring? The debate reminds us that sometimes the boldest ideas emerge from the gaps in our knowledge. Up next, we'll revisit a moment when hope and misunderstanding collided the day a comet's signal was almost mistaken for a message from another civilization. Now let's turn the clock back to a moment that sent ripples through the scientific community. In 2008, astronomers picked up a signal so unusual that for a brief, electrifying window, it was flagged as a potential alien beacon. The excitement was palpable. Here was a rhythmic, repeating pattern emanating from what appeared to be a comet, but its structure was eerily deliberate. Unlike the chaotic emissions typically associated with cosmic bodies, this one seemed almost crafted, sparking whispers of first contact. The initial analysis suggested the signal's pulses were too evenly spaced to be natural. Teams scrambled to verify the findings, with some researchers even drafting protocols for how to respond if this turned out to be extraterrestrial in origin. But as more data poured in, the truth became clear. The signal was coming from Comet Linear, and its peculiar rhythm was the result of solar wind interacting with the comet's unusually dense plasma tail. The message was nothing more than a cosmic illusion, a trick of physics. This episode taught astronomers a critical lesson about jumping to conclusions. The tools we use to search for extraterrestrial intelligence are finely tuned to spot anomalies, but nature often mimics the artificial. The false alarm also highlighted the need for rigorous verification today. Signals undergo multiple layers of scrutiny before any extraordinary claims are made. Yet, the incident remains a fascinating case study in how hope and science intersect, reminding us that the line between discovery and misinterpretation is thinner than we think. Next, we'll encounter a celestial choir, a family of comets whose harmonized frequencies left researchers wondering if they were witnessing coincidence or cosmic symphony. Now, let's shift our gaze to a moment when the cosmos seemed to hum in unison. In 2012, astronomers observed something extraordinary, a cluster of comets emitting eerily harmonized frequencies, as if performing a celestial symphony. This wasn't just one comet singing into the void. It was an entire family, their signals weaving together in a way that defied simple explanation. At first, researchers assumed it was a fluke, a random alignment of cosmic noise. But as they analyzed the data, the patterns became harder to dismiss. The frequencies weren't identical, yet they resonated in a way that suggested a shared origin or influence. Some speculated that solar wind or magnetic fields might have synchronized the emissions, while others wondered if the comet's compositions, perhaps similar icy structures, played a role. Then came the wilder theories. Could these comets be talking to each other or even to something else? The idea of natural objects coordinating their signals was as thrilling as it was controversial. Skeptics pointed out that harmony doesn't imply intent after all. Wind chimes sound beautiful together without any conscious design, but the sheer improbability of the event kept the debate alive. What made this cluster especially intriguing was its timing. The harmonized signals appeared during a period of heightened solar activity, leading some to propose that the sun's outbursts acted like a conductor, orchestrating the comet's emissions. Yet, even with this plausible explanation, the event remains a tantalizing mystery. Was it a cosmic coincidence or a glimpse into a deeper, unseen connection between these wandering icy bodies? As we ponder this, another question lingers. If comets can harmonize by chance, what other celestial music might we be missing? The universe, it seems, still has a few surprises up its sleeve. Now, let's venture into one of the most mind-bending theories yet. Could some of these mysterious comet signals actually be echoes from black holes? It sounds like science fiction, but a handful of astrophysicists have floated the idea that the strange pulses we've detected might not originate from the comets themselves. Instead, they could be distortions, shadows, if you will, of black hole activity, warped and redirected by the comet's icy tails. Here's how it might work. Black holes are notorious for bending space-time around them, and their violent interactions, like swallowing nearby matter, can produce bursts of energy. If a comet happens to pass through the right region of space, its trail of gas and dust could act like a cosmic funhouse mirror, twisting those black hole signals into something unrecognizable by the time they reach us. The result, a bizarre, seemingly artificial pattern that leaves scientists scratching their heads. Of course, this theory isn't without its critics. Some argue that the distances involved make this scenario wildly improbable. Black holes are light years away, and comets are relatively tiny. But supporters counter that space is full of surprises. After all, gravitational lensing, where massive objects bend light, is already a proven phenomenon. Could comet trails create a similar effect on a smaller scale? What makes this idea so compelling is its potential to explain signals that otherwise defy categorization. If true, it would mean some of the messages we've attributed to comets might actually be cosmic ventriloquism, black holes speaking through icy intermediaries. It's a reminder that in the vast theater of the universe, even the most mundane objects might play unexpected roles. So the next time a comet signal puzzles astronomers, maybe we should ask, is this the comet's voice, or is it something far darker echoing across the void? Now, let's shift our focus to something a little closer to home. Well, at least in cosmic terms, while black hole echoes stretch the limits of our imagination, there's another explanation for these strange signals that's rooted in the chaotic dance of particles right around the comets themselves. Enter the plasma wave mystery. Comets aren't just icy rocks drifting through space, they're surrounded by a swirling cloud of charged particles, a superheated soup of electrons and ions known as plasma. When a comet gets close to the sun, solar radiation blasts away at its surface, turning frozen gases into this electrified haze. And here's where things get interesting. Under the right conditions, plasma can generate waves, ripples of energy that vibrate at specific frequencies, almost like a cosmic radio transmitter. Scientists have actually recreated this phenomenon in labs, using powerful magnets and vacuum chambers to simulate the environment around a comet. What they've found is startling. These plasma waves can produce signals that look eerily structured, some even mimicking patterns we'd expect from artificial sources. For example, certain frequencies might repeat at regular intervals or spike in ways that don't match typical natural noise. It's almost as if the comet is humming a tune, but the melody is just the result of chaotic physics. But why does this matter? Because it gives us a plausible way to explain some of the head-scratching signals we've picked up over the years. Take the so-called singing comet cluster from 2012. Those harmonized frequencies might not have been a coordinated message, but the result of similar plasma interactions across a group of comets. Even the Morse code controversy could have roots here, with plasma waves creating pulses that, by sheer coincidence, resemble human-made patterns. Of course, not everyone's convinced. Critics point out that lab conditions are controlled while space is messy. The exact mix of solar wind, magnetic fields, and comet composition out there might not always line up to produce these signals. But supporters argue that's exactly why we need to keep looking, because if plasma can fool us once, it could be hiding other secrets in plain sight. So the next time a comet signal seems too strange to be natural, remember, sometimes the universe's greatest tricks are played by the most ordinary forces. And plasma, it turns out, might be one of the best illusionists of all. Up next, we'll dig into a Cold War-era discovery that was nearly lost to history, a signal buried in Soviet archives that could rewrite what we know about these cosmic messengers. Now, let's turn the clock back to a time when space exploration was as much about scientific discovery as it was about political rivalry. Hidden in the shadows of the Cold War, Soviet probes made a detection that slipped through the cracks of history until now. In the late 1960s, as the space race was in full swing, Soviet scientists were quietly monitoring a series of deep space signals. Among them was one peculiar transmission picked up by a probe near the orbit of Mars. Unlike the usual cosmic noise, this signal had a distinct, almost rhythmic pulse. But here's the twist: it wasn't reported to the international community. Instead, it was filed away in classified archives, labeled as an anomaly and forgotten for decades. Fast forward to 2018, when a team of researchers digging through declassified documents stumbled upon the old data. What they found was baffling. The signal's frequency matched none of the known natural sources at the time: no pulsars, no solar flares, nothing. Even stranger, it bore a faint resemblance to some of the unexplained comet signals we've discussed earlier. Was this a coincidence, or had the Soviets accidentally intercepted something far more intriguing? Some theorists suggest the signal might have come from an interstellar comet passing through the solar system unnoticed. Others argue it could have been a glitch in the probe's instruments after all. Early space technology wasn't exactly flawless, but here's the compelling part. The signal's timing lines up with reports from amateur astronomers in the same era, who noted unusual radio bursts from a patch of sky near where the Soviet probe was pointing. Could they have been listening to the same cosmic whisper? The real mystery, though, is why this signal was buried in the first place. Was it dismissed as interference, or was there something about it that made the Soviets hesitant to share? We may never know for sure, but one thing's clear: this forgotten discovery reminds us that the history of space exploration is still full of untold stories waiting to be unearthed. And speaking of untold stories, our next signal takes us into the digital age, where artificial intelligence flagged something even human experts couldn't explain. Now, let's step into the cutting edge of cosmic discovery, where artificial intelligence is rewriting the rules of what we think we know. In 2021, a machine learning system scanning data from the Atacama Large Millimeter Array made a startling observation. It flagged a signal from a distant interstellar comet as anomalous, not because it matched known patterns of interference or natural emissions, but because it defied them in ways even seasoned astronomers couldn't immediately decipher. Here's what made this discovery so extraordinary. The AI wasn't programmed to look for anything specific. Instead, it was trained to spot deviations from the norm, the cosmic equivalent of hearing a wrong note in a symphony. When it singled out this signal, researchers initially assumed it was a glitch. But after weeks of cross-checking, they realized the AI had detected something genuinely unusual: a series of pulses that didn't align with any known comet behavior or man-made noise. What's fascinating is how the signal stood out to the algorithm. While human analysts might have dismissed it as random static, the AI recognized a subtle mathematical structure buried in the noise. Some scientists compared it to finding a hidden message in the static of an old radio, except in this case, we don't even know if it is a message. Could it be an unknown natural phenomenon, like plasma interactions in the comet's tail behaving in unpredictable ways? Or does it hint at something more complex, something our current models of physics can't yet explain? The debate gets even more intriguing when you consider how the AI's black box decision-making works. Unlike traditional analysis, where scientists can trace every step, machine learning often operates in ways even its creators don't fully understand. So when it flags a signal as anomalous without clear justification, it leaves researchers with a tantalizing puzzle. Are we seeing the limits of human perception, or the first glimpse of a cosmic mystery we're not yet equipped to solve? This brings us to our next enigma, where the very fabric of space might be playing tricks on us, because sometimes the universe doesn't just send signals, it bends them. Now, let's turn our attention to a celestial phenomenon that's as beautiful as it is mysterious: the zodiacal light. This faint, ethereal glow, often visible just before dawn or after dusk, has long been thought to come from sunlight scattering off dust particles in the inner solar system. But what if this cosmic haze holds a deeper secret? Some researchers argue that the zodiacal light might be more than just space dust. It could be entangled with the strange signals we've picked up from interstellar comets. Here's where the controversy begins. A handful of astronomers have noticed peculiar overlaps between the timing of certain comet signals and fluctuations in the zodiacal light's intensity. One theory suggests that as comets pass through these dust clouds, their tails interact with the particles in ways that generate unusual radio emissions. Imagine throwing a stone into a calm pond. The ripples it creates aren't just random. Could comets, in a similar way, be stirring up the zodiacal dust to produce signals we're only beginning to detect? Not everyone is convinced, though. Skeptics point out that the zodiacal light is a diffuse, widespread phenomenon, while comet signals are often highly localized. They argue that linking the two is like blaming a gust of wind for a single falling leaf, possible, but hardly conclusive. Mainstream science tends to dismiss the connection as coincidental, attributing any signal overlaps to background noise or instrumentation quirks. Yet the debate gets even more intriguing when you consider historical records. Centuries ago, astronomers like Kepler and Brahe documented unusual brightness variations in the zodiacal light, events that sometimes coincided with reports of talking comets in medieval texts. Could these ancient observations hint at a long-overlooked relationship, or are we seeing patterns where none exist, driven by the same human tendency to connect dots in the cosmos? Whatever the truth, this puzzle reminds us that the universe still has surprises hiding in plain sight. And as we'll see next, some of those surprises might be echoing from the shadows of black holes themselves. Now let's venture into the cosmic dance of gravity, where chaos reigns and signals emerge from the unpredictable. Picture this: not one, not two, but three comets locked in a gravitational tug of war, their paths twisting and tangling like a celestial knot. This is the three-body problem, a puzzle so complex even Newton himself couldn't crack it. And here's the twist: some researchers believe these chaotic interactions might be the source of bizarre radio signals we've detected from deep space. When multiple comets orbit close to one another, their gravitational pull creates a frenzy of motion. Tails stretch and snap, dust clouds collide, and charged particles get whipped into frenetic swirls. Under these extreme conditions, the usual rules of comet emissions go out the window. Instead of steady, predictable radio waves, we get bursts of noise that seem almost engineered. One theory suggests these chaotic systems act like natural amplifiers, converting gravitational energy into electromagnetic pulses that leap across frequencies unpredictably. But could this really explain some of the stranger signals we've picked up? Take the case of a trio of comets observed in 2012. As they swung past one another, telescopes recorded a series of rapid-fire radio spikes, each one lasting mere milliseconds, yet packing enough energy to dwarf typical comet emissions. Skeptics argue it's just cosmic static, the inevitable result of overcrowded orbits. Yet others wonder, what if these chaotic systems are hiding something more? After all, nature rarely does anything without a reason. The intrigue deepens when you consider how rarely we spot these multi-comet clusters. Most interstellar visitors travel solo, making these gravitational tangles a rare spectacle. That scarcity makes the signals they produce even harder to study and easier to misinterpret. Could we be mistaking natural chaos for something deliberate? Or is the universe using these chaotic dances to send a message we're just beginning to hear? As we untangle this cosmic riddle, one thing's clear. Gravity's wild side might hold the key to some of space's most enigmatic whispers. And speaking of cosmic whispers, our next signal takes us even deeper into the unknown, where echoes from the abyss of black holes might be playing tricks on our instruments. Now let's turn back the pages of history, where the night sky was a canvas of mystery and comets were seen as celestial messengers. Long before radio telescopes, medieval astronomers documented strange phenomena they called talking comets, flashing lights and eerie sounds accompanying these cosmic visitors. Could these ancient accounts hold clues to the unexplained signals we detect today? Take the case of the Great Comet of 1166, recorded by Chinese and European stargazers alike. Chronicles describe it emitting rhythmic pulses of light like a beacon in the dark. Some even claim to hear faint musical tones as it passed, a detail modern skeptics dismiss as folklore, but one that eerily mirrors today's harmonic radio signals. Fast forward to the 1500s, when Tycho Brahe noted a comet that seemed to answer the flicker of distant stars with delayed flashes of its own. Coincidence or something more? What's fascinating is how these historical reports align with modern anomalies. The talking comets of old often appeared during planetary alignments, times when gravitational forces could have twisted comet tails into natural antennas, much like the chaotic three-body systems we discussed earlier. Even the descriptions of celestial voices match contemporary accounts of low-frequency radio waves, which, if strong enough, can vibrate physical objects, creating audible resonance. Yet here's the twist: many of these ancient comets were also linked to earthly events, wars, coronations, plagues, leading scholars to debate whether the signals were real or imagined. Could cultural bias have shaped these records, or did pre-industrial skies, free of light pollution and radio interference, reveal phenomena we've since forgotten? As we bridge past and present, one truth emerges: humanity has always listened for meaning in the cosmos. Whether medieval omens or modern radio bursts, the urge to decode these signals unites us across centuries. And that brings us to our next mystery, a hypothesis so bold it challenges the very fabric of physics, the dark matter echo. Now, let's venture into one of the most controversial theories yet, where the invisible meets the inexplicable. The dark matter echo hypothesis suggests that some of these mysterious comet signals might not be coming from the comets themselves, but from something far more elusive: dark matter. Imagine this: dark matter, that invisible substance making up roughly 85% of the universe's mass, doesn't interact with light or ordinary matter the way stars and planets do. But what if, under rare conditions, it could? A handful of astrophysicists propose that when interstellar comets pass through dense clouds of dark matter, their nuclei might trigger faint, detectable ripples, echoes in the form of radio signals. These wouldn't be deliberate messages, but accidental byproducts of an unseen cosmic dance. The idea gained traction after a 2018 study noted odd energy spikes from comet Borisov that didn't match known comet behavior. Instead, they aligned with theoretical models of dark matter particles decaying or colliding in unusual ways. Skeptics, of course, point out the glaring issue: we've never directly observed dark matter, let alone confirmed how it interacts. Mainstream scientists argue these signals could easily be explained by plasma turbulence or instrument errors. Yet the theory persists, fueled by one tantalizing detail. Some of the strangest signals, like the harmonic pulses of Hale-Bopp or the binary-like code from ISON, appear statistically clustered in regions where dark matter is predicted to gather. Coincidence, maybe, but it's a reminder that the universe still holds puzzles we're only beginning to piece together. So where does that leave us, at the edge of known physics, staring into the dark? Whether these signals are cosmic static or something more profound, they challenge us to keep questioning and listening. And with that, we arrive at our final mystery, the silence after the storm. Now, as we reach the final chapter of our cosmic detective story, we're left with one haunting question: why did so many of these strange signals vanish without a trace? The silence after the storm might be the most puzzling mystery of all. Take the Whispering Comet of 1987, for example. Its eerie repeating pattern captivated astronomers for weeks, then faded into nothing. The same happened with Comet McNaught's abrupt signal in 2007, and the Laughing Comet's viral radio bursts in 2020. No follow-up detections, no echoes, just silence. Scientists have two main explanations, and both are unsettling. First, these signals might be one-time flukes, cosmic accidents we were lucky to catch. Comets are unpredictable after all. Their tails interact with solar wind, their nuclei crack under heat, and their paths cross chaotic magnetic fields. A fleeting burst of radio noise could just be the universe's way of reminding us how much we don't know. But the second possibility, these weren't accidents at all. Some researchers argue the signals stopped because whatever caused them, natural or otherwise, wasn't meant to last. Think of it like a door briefly creaking open in the wind, then slamming shut. If that's true, the real challenge isn't just detecting these signals, but being ready for them when they appear. Here's the kicker: modern telescopes are now scanning the skies 24/7, armed with artificial intelligence to spot anomalies in real time. Yet, even with all that tech, we've never recaptured a single one of these 25 unexplained signals. That absence speaks volumes. It tells us that space isn't just hiding answers, it's asking us to rethink the questions. So what's next? The hunt continues, of course. Every new interstellar comet brings fresh hope, and every silent night sky is a reminder that the universe loves a good mystery. Maybe the next signal will last long enough for us to solve it. Or maybe, just maybe, the silence itself is the clue we've been missing all along. And so, we circle back to where our journey began: 25 whispers from the cosmos, each one a riddle wrapped in ice and dust. From the repeating pulses of 1987 to the laughter-like bursts of 2020, these signals defy easy explanation. Some dance on the edge of natural phenomena, while others tease us with patterns that feel almost intentional. The line between comet and messenger, between accident and design, has never been blurrier. What binds them together isn't just their mystery, but what they reveal about our place in the universe. We're detectives sifting through static, piecing together clues from celestial visitors who might not even know we're listening. Every unexplained signal is a reminder space isn't silent. It's just speaking a language we're still learning to understand. So keep looking up. The next great cosmic mystery could streak across the sky tonight or 100 years from now. And when it does, you'll remember these 25 signals not as answers, but as invitations to wonder. What do you think these interstellar enigmas really are? Natural quirks, something more? Drop your theories in the comments below, and let's keep the conversation as alive as the stars themselves. Don't forget to like, subscribe, and hit that notification bell so you never miss a cosmic revelation. The universe is full of stories waiting to be told, and we're just getting started. Until next time, stay curious and keep your eyes on the skies.